welcome to the Mindplex Pubcast. We are here live today with Hypercycle. We have Toufi Saliba. Toufi, say hello.
Hey guys.
Yay!
Hello.
And Dan Toliver, the CTO. How is it going, Dan?
Hi, everybody.
Great. And then we have our own Dr. Ben Goertzel, who is CEO of SingularityNET and also chief scientist for Hypercycle. What's up, Ben?
Hey.
Okay, great. So all sorts of stuff has been going on with Hypercycle the last couple weeks, and I'm just going to let Ben and Toufi sort of take it away and let us know, what they want to tell us and how they want to let us know.
I was thinking we let Dan take it away. Actually, I mean, yeah, but
I would love to. I don't know how much my voice can take right now. I'm recovering from the plague.
Yes, I didn't have a chance to tell you, Ben, but yeah, Dan's going to take it easy today, probably. Okay, but somebody take it away. Toufi, why don't you take it away? Let us know about the new stuff that's been going on.
Okay, cool. So this is actually Dan is not faking it, and for those that they still think that he's like AI, if he is, he's very, very good at it because he does get sick like the rest of us. So guess what? He's sick right now, and look at him. He's got that cough and all that. So
let's get that going.
We were going to not draw too much attention to it, but that ship has sailed. So anyway.
Right. So a lot of stuff been going on in Hypercycle. We feel like we're doing this convergence where we're putting on a lot of efforts from two ecosystems, and when you feel like ecosystems that they talk a lot about something, and then finally they kind of put it together and they make it, and then we kind of like treat it like this baby that we wanted to be exemplary to many other babies, and so it's a lot of pressure on that baby, and it's kind of like I'm the eldest in my own family, and it's like if I smoke, everybody smokes. If I do anything, it's all blame on me. So I have to, put all this pressure. So I feel like
it's a lot of pressure.
With if you look at SingularityNET ecosystem, there's a lot of babies there. With Toda ecosystem, there's a lot of babies, but this is joint baby has been in the talk for so many years. We tried to do it with Todalarity, but then COVID happened. We tried to do before that many different things, Goertzel and all that, and now we feel that the timing couldn't be better when we started doing this together. October 22nd is when we open up the Hypercycle store, as you know, and the revenue started growing slowly and then started accelerating. Up until now, Lisa, we have sold 241,000 notes. Okay, that's huge. You know what has been the biggest problem since we last talked? The bottleneck right now is finding tokens somewhere to kind of fill them up. Like literally, that is the problem that we're dealing with. Like there's so much demand from the nodes that they want to absorb those tokens. So which means we may have to have like a certain like board meeting to touch the treasury to allow those to go in towards the native token. We have June 20th is the very first stilling that actually started more so like pre-beta. We have several pre-betas that we let them run to make sure that they're actually running, and any hiccups, we want to be the first to kind of notice it. We have also announced a partnership that is called HyperPG. And it's kind of, if you think about it, it's like, what is HyperPG? It's kind of like this baby's already having babies, kind of like a grandchild type of thing. Because we did this partnership with Penguin Digital. They have a lot of infrastructure. They also have a school in Switzerland for coding, in Germany. And they went and opened up this facility towards computing. And Of course, they ended up doing lots of mining with that, but then they started doing, they realized that they want to do in parallel to mining AI computation. Then many people, they started realizing that it can be very profitable to do AI computation. Remember, that's what they're doing. This is not what we do. We provide the network. That's our clients. They do AI computation. The way it started as a customer that they bought, software licenses, and then ended up doing this partnership with them that is called HyperPG, which is very well suited to kind of put the pieces together. Because when you look at Hypercycle, if you run a Hypercycle computation node, there are a bunch of beneficiaries. Okay, there are beneficiaries that they have, like the token holders. There are beneficiaries they have the license holder. There are beneficiaries they have the hardware. Those guys that run the machine. There are beneficiaries they have the facility, because the facility has to exist somewhere. Is it on the moon? If it's on the moon, you need to pay rent for the moon, right? And if it's on Mars, you need to pay rent there. If it's on Earth, you have to pay rent. So point is that these guys, they provide the facility, they're putting in effort, hardware putting in effort, and last not least, the AI coders. If you built an AI, you want to put it there, you're one of the actual beneficiaries. They're in the actual Singularity ecosystem. There's a lot of efforts that's been done to kind of get that AI up and running a lot faster than if you were to be building it from scratch. There's also distributed computing that NewNet built that we're also working nicely with them and see how we can fit the pieces together. So when there's like 5 beneficiaries, who is gluing them together? Turns out HyperPG can do great work at that. So that baby number 1 was announced. It was picked up by over 80, channels across the globe when we announced it. So it's got a very good audience. There's an about 7 or 8 minute video of a documentary that we did it documentary style when we actually went to tour the facility in Paraguay. And it's on HyperPG. If you want to see it, you can hyperpg.com. You can find the video there and you can watch it. It's a fun video. And since we last talked, we got HyperASICs up and running. HyperASICs is that think of a motherboard that can handle 5 ASICs at the same time. So we went to hardware facilities in Korea and got them to start bidding, and then got one of them to start working on a model that they're going to show it off over the next couple of months. We've got a CTO working there, a phenomenal CTO, and he's doing great work at that hardware. It's not our expertise in hardware, but the reason why we're doing HyperASICs is we felt like there's a lot of demand for a lot of AI scientists to have one single computer that can do multiple different ASICs in it, as opposed to like one computer specialized for a specific thing, another one for something else. And then we revived something called Goertzel, which is an idea that Ben and I talked about a long time ago. And as we started launching it before COVID, and we stopped, and then now we decided to do it again, and which is basically, it's like an accelerator. But this time we thought, why do an accelerator like everyone else? Like if you go and put startup accelerator right now, Lisa, what do you find? Billions of probably accelerators, more than people. You might find more than 8 billion people, 8 billion accelerators out there. But you are not going to find any single hardware-only accelerator. So that's what it is, Goertzel, hardware-only accelerator. And with that, we then approached one of the companies in the ecosystem, Simulai, and begged them to let us in. They got us in, so we got them into this accelerator as well. It's still actually, we're in the process of actually signing the docs and getting all the transactions. We've got Integral Semiconductor, and that's somebody's an ex-MIT who's worked with retired professors in MIT and some top folks with in the hardware that they're doing it in integer-based ASIC. So all of those ASICs, they're specialized for certain things in AI, and each and every one of them, they can run on the same machine, which is super cool. And the The one that we've placed an order earlier today is somebody that we ran into at the AI for Good Summit with one of our super duper advisor who has been doing advisors on both sides of those ecosystems, who known us for quite some time, and right now she's helping us a lot with Hypercycle. Her name is Mihaela. Folks, they know that she's very well published and taught in many universities and whatnot. So she ran into somebody who went into grad school back in Berkeley, like 30 years ago or whatnot. And he was at the AI for Good Summit. And what does he do? He builds those appliances. It's like a box. And all he does is that this box, he sells it to many different homes. Those homes, you put the box, and what it does some sort of like computation. Of course, the very first thing that people do, they do like mining. When Mihaela told him AI computation, he's like, that's what I actually wanted to do. Can we meet these guys and whatnot? So as soon as we signed a purchase order with him, then we've got these huge backers who came in and said, if you were to use those 2 factories, then we can provide you in South Korea. We can provide you with the sponsorship for about 52,000 devices. We're like, where do we sign? Today. Lisa, you're the very first to hear about it, okay? So that's
Yay! You heard it here first.
I mean, I should be a little bit with you. Dan heard about it a little bit before you, but I haven't had the chance to
count. He's in the company. I
haven't even had the chance to tell Ben. Okay, this is fresh.
Oh.
Yes,
Right.
but we covered it.
Ben likes surprises.
Right. We covered it at CXO. Today we usually have
Depends what they are. Yeah.
Yeah, good ones are okay.
So yeah, a lot of exciting stuff happening in Hypercycle, but as you know,
so just to be clear, so you signed a hardware deal to manufacture specialized chips or boards or both, or let's clarify what's happening here.
Lisa, it's a box. You take it, you plug it in every cold country in the world. They need a heater.
What's inside the box is?
It's a heater. Like, let's say you live in Sweden, you need the electric heater. You plug it into the wall. Guess what? You don't have to pay for that heater. It pays you money every day, about $10, maybe 20, and it tells you, it's got a display how much AI computation is doing. You can actually swipe and configure what kind of AI computation, if you care more about like cancer research versus like some sort of like financial research, just because you care about some sort of ideological things, you could. But that's all you do if you want to do. But if you don't want to do anything, you just keep it. You just plug it into the wall, and it does the rest on its own.
So it's computing whatever it is and generating heat.
Yes, because cold countries, they like to generate heat in their homes.
Yes, I have a friend. Exactly, I have a friend of mine who's very into this.
Must be Homo sapien, like they like heat in the cold countries.
Yeah. So that's a great. Okay, so that's a new, completely different project than anything that we've talked about thus far.
It's just that.
Well, it's not that. I mean, it's just
not the computing part.
Hypercycle node run.
Right. So this is a way for you to get some of those computational nodes that you were just saying you needed, right?
Right. So we felt like we had the hardware as a bottleneck at some point, and as we're discussing that, we came across it. They provide us with a deal to do purchase. We decided to make a purchase order for a very small amount, and when we started talking to some Korean factories, they said, if you want to do large amount, we know certain sponsors who come in and sponsor the whole thing. So we're like, can we talk to them? They came in and they sponsored on our behalf, because 52,000 devices, they would cost us about $52 million. And we're not a hardware company, but if somebody wants to do it and have our software already installed in there, and you just like anyone who's going to order it, they can just like get it, and the software's already there. That's a good thing for us, good thing for them. Everybody wins,
Okay. All right. Great.
They have all of the stuff.
Yeah, I mean, this is, Lisa, this is about the decentralization of the hardware infrastructure, right? So, I mean, a network like Hypercycle, in principle, can be massively decentralized, right? I mean, you could put a processing node on everyone's phone and then do AI computation in this massively decentralized network. But I mean, in practice, you have to figure out how do you get people to run powerful enough machines to do the interesting bits of AI computation needed for decentralized AI, right? So I mean, it doesn't need to be individual people in their houses to be decentralized. Of course, it can be mining farms, it can be companies, it can be people who own server farms, and you have AI running in each of these, server racks in these processing farms, and you still have the advantage of decentralization. There's still no central owner or controller. On the other hand, if we can fractionate yet further and have individual people in their houses running hypercycle nodes, or then running AI on SingularityNET or whatever, I mean, that's even better, right? So now we have a concrete move toward getting that extra level of decentralization, where you have people in their individual houses running hypercycle nodes, and then these sort of home computing boxes are connected to the same network as different server farms running on hypercycle network. And I mean, that's as Toufi said, we've been talking about doing this for quite some time, and the software automatically supports it, but having the partnership to fill in the hardware part is certainly interesting, right? And this is
interesting. It's a pretty big deal. I think it's a game-changing kind of thing. Being able
it's cool.
So Rainer, cut to Toufi so we can see he's holding up a picture. Is that one of these boxes?
Yes.
All right.
This is it. But the team decided that they will call it Hyperbox or Hyper Appliance because we want to maintain Hypercycle to be just like the actual network. And this is it.
Appliance. That's so funny. I haven't heard about web appliances since the 90s. Let's bring that back.
They either, like, because it looks like retro. It looks like the Ataris, So
it does.
It's anyway,
that's
so
we're thinking of putting a hypervector chip in there so we can call it the Hypercycle Hypervector Hyper Appliance. It's kind of a mouthful.
What you wish for.
I had a call this morning with the guys from this hosting service called Spheron, so then we can do the Hyperspheron also, right?
Yeah.
So I mean,
there you go.
Now you're just doing partnerships for funny names. I can tell that this is
well. No, I mean, I think that the criterion for choosing a partnership should be whether there's a bad pun you can do with the name of the partner, right? I mean, it saves a lot of energy.
Why the name can matter so much.
4-dimensional technology in there, and if we do that, then Hyperspheron is perfectly appropriate.
If string theory is correct, the higher dimensional technology is always in there, right? It's just a matter of how much attention how much paying to that level.
How much we can exploit that.
Cool.
But I think I mean, you mentioned the hypervector chip, and we probably will put that in there eventually.
I was just gonna say that's actually makes perfect sense to put one of those in there and to keep putting stuff in these things.
This ties in with some more theory and oriented developments that are also interesting to briefly chat about, I guess. So you could
also watch episode 2 of our podcast with Rachel St. Clair, in which we go into this.
Well, that's true, but
greater detail.
That's old news now. There's a lot of new stuff beyond that. We got to do another one with Rachel sometime. So I think so. One thing I've been working on with Rachel and various colleagues is using hypervectors to accelerate the meta programming language, which we've developed as the AI language of the OpenCog Hyperon AGI system, but we also intend to use as a sort of core smart contract language in Hypercycle. And so Met, it's its own language we developed for the OpenCog Hyperon AGI system, but we're working with Greg Meredith from Firefly and Rolang project, and we have a source-to-source translator from Meta into Rolang, which is a smart contract language originally developed for the R-chain blockchain. And so one thing we will start working on in a couple months is integration of Meta/Rolang into Hypercycle, right? So I mean, Hypercycle can support a variety of different virtual machines corresponding to a variety of different smart contract languages, but I think there's particular value and promise to running Meta/Rolang smart contracts in Hypercycle. This gives scalability of a different sort. So the type of scalability you've traditionally been able to get from Rolang has to do with running on multiple cores and effectively exploiting the hyper on the multiple cores, and that sort of parallelism is quite valuable for efficiently running AI payloads. But what we've been exploring now is how to use hypervectors to get even more parallelism out of Meta/Rolang. So we've been looking at the GSI associative processing unit, which is basically it's a processor in RAM chip that gives your processors immediate access to quite large amount of memory. And what Greg and Adam Vandervorst and Rachel have been working on is taking language, which we're translating Meta into to run AI processes efficiently. So we've been taking Rolang language, mapping Rolang into hypervectors, and then you can run those hypervectors math very efficiently on the GSI associative processing unit, right? So this lets you do Rolang stuff and therefore Meta stuff much faster if you have that special chip. Now these boxes that Toufi just showed you do not currently have a GSI chip in there, but it's a possible thing to do. Now the custom hypervector chip that Rachel and I are working on, then the custom OpenCog pattern matching chip we're working on. I mean, this would be the next level and would give you even more improvement than using the GSI chip. But I think there's going to be a series of faster and faster hardware that then accelerates the AI running on Hypercycle, and also accelerates some of the smart contracts that are doing sort of secure processing operations in the Hypercycle network. So I mean, we can start out now with these boxes that we already have that can run various sorts of AI processing within Hypercycle node. Then we can gradually upgrade the boxes over with various specialized chips for which we have specialized compilation processes that let AI and let smart contracts run really, really fast. And I mean, it's very much the analog of what's happened with GPUs for deep neural nets of various sorts. I mean, we've seen GPUs. I mean, in theory, they don't let you do anything you couldn't do on CPUs, but they've just made it way cheaper to do deep neural net stuff quickly, which has been much of what's enabled the deep neural net revolution, of which the large language model revolution is a portion, right? So what we're going to see in the coming couple is different sorts of specialized hardware besides GPUs that allow broader classes of AI algorithms to be radically accelerated. And so we will then be at the forefront of this with Hypercycle via these newfangled processor hardware into these Hypercycle boxes, as well as into the servers on Hypercycle dedicated server farms. And then what this means on the AI level is you can run your deep neural nets and large language models, but you could also run, say, logical theorem prover or hypervector powered episodic memory, or you could run evolutionary learning for creating new art or new music or new text, right? So you can run a variety of different AI algorithms that are accelerated by these different new chips, and they can all be wrapped up in these boxes that coincidentally also keep your toes warm at night, right? So there's a lot of interesting sorts of technology advance all integrated together, and this stuff, it's rolling out surprisingly rapidly. I mean, I would say there's not that many times in my career when I've seen systematically a bunch of things rolling out a little bit faster than envisioned rather than slower than envisioned. And so, of course, it's not going to happen all the time. There's all sorts of hidden rocks and complexities in building things of the level of sophistication that we're doing. But still, I think we're entering a regime in AI and blockchain and other associated technologies where a decent number of things are going to be happening faster than planned, right? Is exactly what you would expect as the technological singularity approaches.
Sure. Hey, we have a question from the audience. Max says, hey, the box looks cool and all, but I still wonder if the chip could be added to a Raspberry Pi device. So I'm wondering about that for both chips. So the chip that you have in your box, in the Hypercycle box, can that be just added to a Raspberry Pi setup? That brings up all sorts of questions. Can the Raspberry Pi, is that enough power to be a computational node?
I would say eventually, but not right away. I mean, these chips are expensive and use more power than would be typical for that sort of deployment. But I guess you need a couple cycles of the manufacturer costs coming down and the power use being optimized for that to be practical. We can put them in Sophia, though. We can put them in humanoid robots, right? So I mean, you can deploy them in a bunch of scenarios. But so what
that have
sufficient
power. That have sufficient power. That's the
I mean,
requirement.
One thing we're looking at with humanoid robots, like say the Grace humanoid robot, which is being developed by Awakening Health and who's been on our podcast many times, right? So we're looking at a situation where you have a sort of server rack in a hospital or an elder care facility, and that's connected by then fast local Wi-Fi with the various robots tooling around in the facility, and then the fancy specialized hardware sort of goes in the server rack. It doesn't have to go on the robot, but it's local to the robot. And I mean, we're also talking to some people about developing smaller home robots that are like, say, 3.5 foot tall or something. But then the special fancy hardware sort of goes in the charging station, which would look sort of like the docking station for a Roomba or something, right? So I mean, you can. It doesn't need to be only in a fancy server farm, but at the moment it wouldn't go naturally in a Raspberry Pi. But I mean, I would say it could be years, not decades off. You just need some phases of refinement of the hardware.
Sure. And I should correct,
We
it was
we
the
ran
Pubcast.
we ran OpenCog.
Yeah.
We
Go ahead.
ran OpenCog on Raspberry Pi 3 some years ago, though. So I mean, you can put a lot of this fancy software on the Raspberry Pi, actually using the hardware that's
Right.
that's there. Yeah,
It's the right idea.
Dagim Sisse. Yeah, Dagim Sisse from our Ethiopia office, who's now a lead developer for NewNet, actually. But I mean, he OpenCog on Raspberry Pi 3 some years ago, and we like bolted that onto the back of a Robo Sapien robot to help make the Robo Sapien to hold more intelligent conversations. And we put it in a Hanson Robotics Professor Einstein bot to upgrade it. So you can get a lot of software on the Raspberry Pi. And I wouldn't be surprised if you could put OpenCog in a Hypercycle node on the Raspberry Pi if you wanted to. So that, I mean, the software wise, actually you could do quite a lot, but this special hardware initially is sort of a server to sit on a rack or one of these specialized boxes, which have the amazing ability to put like the stuff you'd normally see in a rack mounted server, to put it in everybody's house.
Right. And I just wanted to clarify, I meant the Pubcast that we just had with Rachel a few months ago, where you really do get into the nuts and bolts of
yeah. But all this hypervector stuff,
and I put that link in chat. Was all I was going to say.
That's great.
Go ahead.
That's great. No, we talked about a lot of amazing stuff there. Actually, this whole connection, Rolang and Meta and hypervectors, and that collaboration with Rachel is conversations that started at the AGI 23 conference in June, and so there's been a whole bunch of development in the last month and a half, actually. So a lot of things are converging.
Everything's going so fast. Quite
rapidly.
Definitely.
One of the interesting things about that from a hypercycle perspective, beyond the increased functionality and capacity for a single hypercycle node in clients or data center acting as a hypercycle node, is the increase in flexibility that we have for building distributed systems between hypercycle nodes so that they can work collectively to solve problems. And the Rolang Meta combination actually potentially gives us more flexibility for creating the kinds of distributed systems that we're interested in there. Rolang under the hood has a very nice facility for sending code from one node to another node and having that evaluated. So you can serialize a piece of a process and send that process over to another hypercycle node and have it perform that for you. And under the hood, Rolang is really based around this idea of sending evaluatable code over channels. In fact, the channels are actually themselves named after evaluatable code. So digging down into that, we get this, and Ben, you mentioned that this is mainly used right now for multi-core parallelism, but we can use this to distribute computation across multiple different hypercycle nodes and have each of them perform the operations that they're ideally suited to.
You definitely can.
And then Meta gives us some flexibility in how we're typing this.
Yep.
Go ahead.
No, that was part of what Greg was aiming for in our chain as well, right? So there's multiple cores, there's multiple like hyper threads within a core, which most software doesn't effectively utilize, and then there's multiple machines, and the same formalism basically deals with all of these different sorts of distribution.
But in the hypercycle system, we have a scenario where the nodes themselves are deeply heterogeneous because each of them is connected to potentially radically different AIMs under the hood. One hypercycle node might be connected to an LLM, another is connected to NewNet, another is connected to OpenCog, another is connected to OCR software. Right? It can be almost anything that you plug into a hypercycle node to give it its computational resources that you're making available to it. And so being able to take a problem and distribute it across the network in a way that takes advantage of the flexible micropayment system we have access to in Hypercycle and lift those economics, including things like gas costs and per computation costs, up into the user addressable process space, while also being able to divvy up the problem among a group of Hypercycle nodes, the neighbors of this one that it knows, and distribute those tasks on a pay per performance basis, or other kinds of flexible arrangements around the economics there. There's some very interesting things that we'll see coming out of the next year with respect to this. First with more traditional languages, but then as we start to introduce meta and Erlang, I think that will open up doors on the Hypercycle side for being able to do that at scale in ways that we haven't really been able to do before in building distributed systems. It's exciting.
Yeah, that's very cool stuff. I mean, the math of mapping Rolang into hypervectors. It's been fun to see Greg and the GSI guys and Adam Vandervoort sort of map all that out, because I remember reading Pentti Kanerva's books on sparse distributed memory back in the 80s. You take these huge sparse Boolean vectors and use them for different kinds of memory and processing. It seemed really cool, but on the hardware of that time, you couldn't quite get it to do what he was envisioning. You just needed more scale. And now it's merely 25 years ago, and we've got hardware to do all that stuff from Kanerva's papers from the 80s and 90s, and it's actually works, right? I mean, I always thought it would work, but it's quite enough to see it actually there. And now you can use it in ways different than he envisioned, right? Because when I originally read about hypervectors, it was more how do you model an episodic memory, and that's of course important from a cognitive science context, and we will use hypervectors to help with the OpenCog's episodic memory. On the other hand, now we're seeing you can also use it sort of to accelerate this language for fast distributed processing, which wouldn't necessarily shock Kanerva, who invented the hypercycle math, but it wasn't the application he was thinking of. I mean, any more than the folks who first invented multi-layer perceptrons, aka deep neural nets, in the 60s were thinking about large language models, right? I mean, once you have the hardware to make a technology actually work, it's going to branch out in a lot of different directions, which is pretty.
So wait
pretty
a minute.
Interesting
Is there a
see.
hypervector implementation on the Hypercycle chip as well, or were you talking? There is
Not yet.
Not yet.
There is not.
Oh,
but,
okay.
But
that's the plan. That's the plan.
No, that's because the point is that we now have a prototype hypervector implementation for Rolang, which is what we're using to implement Meta, which is a smart contract that we're developing for Hypercycle. So we have for one of the key Hypercycle smart contract languages, we have a hypervector, and we're putting that onto the GSI chip, and we'll later put it on the Rachel's chip. So that's, but we don't yet have
the GSI chip is what you're talking about. That's in the Hypercycle device.
No, it's not. You're confused.
No, what's the chip in the Hypercycle device called? How do I refer to it?
Potato chip.
Very funny. It's a potato chip?
Yeah, it's.
How do you refer to the Hypercycle chip?
It's toasted by the heater in the box. That's right.
Right. Yeah. That's actually not a bad branding idea. Somebody write that down. So do you just call it the Hypercycle chip? What do you call it?
No, we don't have a custom chip in
that chip isn't custom.
You don't. Okay.
Yeah, we're not in hardware. We're in network, and when we get into those partnerships, it was like a certain hardware. It's either to have a box to enable many of our customers to get a little bit faster implementation.
Right. And
Motherboards
that's
have
actually a
that.
selling
Yes,
point, that you don't need a specialized
Yeah,
hardware to run
So
these nodes. That's
currently,
the whole point.
Correct.
Got it.
correct.
And
currently
the
we have
hypercycle architecture is compatible with whatever custom chips you want to throw at it. Because remember, the nodes themselves are heterogeneous. So my hypercycle node can be doing computation on a very specialized custom chip, an analog chip even, and then converting that back to digital and sending it out over the network. Yours can be doing something totally different. And both of those are available within the hypercycle marketplace for responding to requests and performing these computations.
Okay.
Yeah, so currently we have this hypercycle box, which has conventional chips in it, but can serve as a hypercycle node. And we also, as a separate initiative, we have a very fast hypervector-based compiler that takes hypercycle smart contracts and can run them on custom chips. So I mean, in future, it's obvious that you could put those together. You could put custom chips in the boxes, but that's
right.
That's for some point in the future. But it will be
Right.
It will be a pretty clear integration to put
Yeah,
the
and the
different
point
pieces
is,
together.
it's all possible. You could use it without anything
Not
special.
not
You
just
could
not
add
just that it's all
specialized stuff.
possible. It's all even straightforward, right? Rather than just possible, right? And so,
Okay, that's
but
better
I
than
think
just possible. Sure.
yeah, I
It's
think
not hard. It's
the-
plug and play almost. It sounds like. I hate to use those words,
well, it's
but
yeah,
it
it's not
sounds
quite.
pretty simple.
It doesn't require any
It's
network
The
level
box-
changes.
The box
You-
gets
you
plugged
can-
in, right?
If
Yeah.
you have to
well,
write the device driver for it, you might have to do that, but you can do that yourself. And no one else has to give you permission to do that or push any
I
changes
don't
out
know if
over the
Lisa
network.
can do
for it
that
to work.
herself.
I have confidence
Very
in
funny.
him. I have faith.
Touche. I certainly
know-
can.
Yeah.
Well, now I have to get one, Ben. Now I have to get one and set it up and show everybody that
Well,
it's so easy, even I can do it.
Lisa,
The cool thing will be when the OpenCog LLM running in the box can write the device driver for Lisa, right? I mean,
No,
that would
I'll
the
always
next
be
step.
smarter than a fucking LLM. So don't worry about that. I won't be
Well,
able
the
to
the
make a
fucking
list.
LLM is a different product.
I won't be. I know what you're always. Yes, definitely. So we've got a bunch of questions. Let's start asking some of these questions
Right.
from people. Okay, this is great. Viewer Max again has asked, I'm trying to put this in perspective with what I imagine you are doing with Zarka. Is it safe to assume that some algorithms will run better in different blockchains, or even combining chains for a single algorithm as well as multiple algorithms on multiple chains?
Well, Zarka is a project aimed at making training LLMs, neural symbolic LLMs in particular, on basically large server farms that are customized for training LLMs, right? So I think certainly the Zarka server infrastructure can leverage Hypercycle on its servers, but I mean Zarka for training LLMs wouldn't use these sort of consumer boxes that Toufi's talking about. I think you could put model inference for LLMs on these boxes, which is valuable, because then if you want to use an LLM like the one Zarka has trained, if you want to use those locally, you could run run, right? So for training LLMs right now, given how that technology works, you really want a bunch of boxes that have very fast wires between them. And as Dan has pointed out, Hypercycle infrastructure, the network can run either on like a dedicated LLM training server farm which is a bunch of processors very tightly wired together, because that's what you want to do to train a large language model in the current knowledge. Or you can use Hypercycle on a more, heterogeneous, widely distributed network, including these boxes running in people's houses, which could then run a variety of different software, and it could include, model inference for Zarka LLM, other LLMs.
Okay, great.
Hey, Lisa, there's actually a very interesting question. I'm sure you have your own order with those questions, but do you want me to jump in, or you want to go through your order? Because I don't want to interrupt your.
You could do either one. So if there's a question that you're hot to answer, go ahead.
Okay, so one of the questions, somebody said that they're new to this. They're just asking what type of security does Hypercycle use, which kind of reminds me to tell folks what is Hypercycle. In fact, when we started describing it, Hypercycle is a security thing. Like, we're not AI. We actually secure certain elements, so then AI can talk to other AI without having to depend on a third party. Its capability is unprecedented, and that's what we do with Hypercycle. So what kind of security do we use in that process is perhaps something that folks can find on hypercycle.ai, because we have a lot of
it's just good old fashioned encryption, right? You're using
I wouldn't say good new, because we use like the latest. Yeah.
Right, but I'm saying you're using the latest and greatest in traditional security that you would use to lock down.
Well, it's not just for this, because I mean, in the foundation of Toda, you have Toda IP protocol, so which bakes encryption into the messaging layer. So I mean, in the way normal computer networks run, you have an insecure protocol, and then you do security to try to make up for that. And the way Toda works, you bake security into the lowest level of application. So I would say it's different than traditional.
Well, that's a good answer. That's what we were.
Traditional security. On the other hand, it's I mean, of course, at the level of encryption algorithms, you're using the same math as everybody else, but you're baking.
You're still using public keys and private keys.
Yeah.
Right.
Yeah.
Correct.
You're using traditional.
Yeah. You're using security. We're not reinventing.
But you're integrating it. Yeah, but you're integrating it into the core communication protocol in a way that should have been done when the U.S. military invented the internet, but they didn't do, right? Like when they invented the internet.
Thank you for saying that.
They were just trying to make things run fast on hardware from the 1960s and 70s, right? And networks from the 60s and 70s. And very hard to make networking work on computers in the 1960s and 70s. So they just weren't worrying about, like, how do you encrypt everything at the application protocol level. And then, we got standards which comprise the internet, which is great. It's very hard to get the world to adopt reasonable standards. Unfortunately, those standards do not involve baking encryption into the basic communication protocols. So we're left with an internet that's insecure. Industries that are based on working around that, and there's no practical way to get the world to adopt new internet protocols that are secure by design. But at least in the stuff that we're building, we can bake security by design into the basic protocols, and this has been at the sort of core plumbing level of Toda since our two colleagues here start. We're using that sort of at the base level of everything inside Hypercycle, which is important, because I mean, honestly, if everyone would shift to using Toda IP as a basic protocol, then you wouldn't need the whole computer security industry, or you wouldn't need 90% of it, because it's all just working around. It's all just working around an insecure plumbing layer at the base of the internet, which is just, it's kind of ridiculous. But I mean, that's how the world works. We haven't even got the US to adopt the metric system yet, right? Like once you get lock-in for something, it's really, really hard to get rid of it. If it works, even if it's very fundamentally flawed, then and people start using it, it's very hard to eliminate it. But for AI, we can sort of start over, right? So if we can build the internet of AI on top of a fundamentally secure infrastructure, and so if we, in the next few years, if we roll out the world's smartest AI on Hypercycle, right? I mean, then suddenly what you have is the internet of AI is fundamentally secure plumbing, right? And then since AI will be the most important thing going forward, then that's a way to, in effect, shift the internet over to a secure infrastructure, because you're shifting the internet of AI to a secure infrastructure, and ultimately AI is going to be everything.
All right. Well, we have another question here.
Hallelujah. Praise the singularity. Yeah.
Someone's asking, praise the singularity. What is the delivery schedule for the 42,000 boxes for Toufi that Toufi is putting out for Hypercycle?
So,
when can we get one, basically?
So the very first, about 1,400, they're coming in about a month and a half, sometime in September. That's the first batch. The 52,000, they come right after that, based on some feedback that we will have our own community to provide. So the one that I showed you might change a little bit, even the look of it. Is some people, they care about the look, I guess. And we're facilitating all that for this thing, like that would be called, let's say, hyper appliance or hyper box. We don't know exactly what the name will be, but what we do know from our perspective from Hypercycle, we have signed that purchase order. We've proceeded with that because that major sponsor who's going to cover the 52,000 devices, they really want us to do this in factories in South Korea. They kind of work with those factories very closely. So we feel super happy about it, and we like to work with a lot of factories around the world. And this one, it's just something that can accelerate the actual nodes across the globe. So why not doing it? So it's not necessarily, again, our core business. We're here to facilitate the network, and like Dan mentioned, and Ben, Hypercycle can truly work on any machine, because it is not the machine itself. It is more like the connector of those machines. In the last podcast we've had with you, I think we've given it that metaphorically, it's more like the synapses of the global brain. So we're just solving that tiny little piece to enable a neuron to talk to another neuron. It passes those electricity and chemicals or whatnot. The synapse is taking care of that. And it doesn't really, synapses, they don't really go and check with any decentralized ledger or central ledger or bank or anybody. They just do it and do it every single time they do it correctly. That's what Hypercycle does. So you can imagine at a big scale, it can do a lot of cool things. And as I'm saying this, I noticed one of the questions, somebody said that, like, how would AGIX and the HYPC kind of work together? You remember, the whole raison d'etre of Hypercycle is to not the other way around. And effectively, those HYPC, so if you think about them as more like, let's say you have your warehouse and you want to send some merchandise, what you really need is that, let's say, UPS truck. HYPC is kind of like UPS truck. Okay, so if you want to send the UPS truck on its own as a payment to your neighbor, you could, but perhaps you want to send AGIX in it or whatnot. So that's it's the method, or NewNet, NTX, or combination of both, because whoever is selling you computation, they're asking for both things. maybe you want to put US dollars, Bitcoin, whatever you want to put in it. You can actually put it inside that HRPC. It is a container. So it's super cool from that perspective, and we feel like it's reaching out to a point where many of those nodes, they become available. They start doing something that is called tilling, because we don't do mining, we do tilling. We borrowed that term from the ERC-64 data structure, and it's effectively tilling. It's basically, look at the ground. If you're doing some sort of like vegetation or whatnot, it's like, when that thing goes into the ground, it starts like making it ready towards some sort of like new vegetation. It's called like tilling. It started when Dan and I were talking with the ERC-64 team, and Dan and I were always like brainstorm separately. And Dan is asking me like, "But what do you want it to express?" And I'm like, "I want it to express certain preparation for something that it's like good, some sort of immersion, something good." He's like, "How about tilling?" And we said it to the folks, and they loved it. So since then, we've been using that term. What do you do with the hypercycle nodes initially? You turn them on, start doing tilling. And then for computer scientists, this is more like setting up the data structure. Computer scientists would be like,
configuring.
Data all in the right places, whatnot. Like, for example, if you were to be working at right now, or any search engine, whatnot, the actual, when the customer typed the search, that's not when the real work is actually happening, or there's some work, even 0.1% or 0.1%. The real work was done ahead of time. There's the scraping, there's the actual placing in the data structure, there all of the stuff.
Index everything, and
right. And that's you're only talking about like information. Now imagine when you're setting up certain infrastructure for value that cannot be lost, has to be deterministic, and of course it's going to require all of this work, and that's what the tilling starts. And with that, it starts gaining value. And why does it gain value? And I can give you here, Lisa. It's more like this wealth creation that people talk about. You know what? This wealth creation actually existed before electricity. This wealth creation existed for a long, long time. Like people, this is our civilization created this. Like, for example, you buy a coffee shop, you take care of it. 6 months later, it has a very good reputation. It has a phenomenal, it serves like 20,000 cups of coffees instead of like 2,000 used to, in that period of 6 months. It's open 24/7 instead of 6 hours. You automatically, if you were to ask anyone on this planet, can this coffee shop be sold for twice more than what I bought it? And everybody would be like, of course. We've asked this question everywhere.
The value has been added, right?
If you spent $1 million, now it's $2 million, where did that come from? That is wealth creation, and that exists in every planet. We ask everywhere. I'm telling you, like, actually, there is one place that I don't know what, it probably doesn't work. It's North Korea. I don't know how they do it over there. It's different. But the rest of the world,
use another example. Yeah, exactly.
I don't know how they do it. Honestly,
another example.
I'm here for everyone, but it works everywhere. So my point is, imagine when you introduce that to the machine. And what does that mean? What does that mean? Imagine you're running this device, or you're running 500 of those devices.
I would imagine that the political system of the country where the box lives does not affect how the box operates.
Right.
It in fact is going to operate the same everywhere. And so one of the viewers asked, can this box be used to do other stuff? I've got this supercomputer running in my house now, crunching things as a node on the Hypercycle network. Is there anything else I can do with that box? It's heating my house. That's good.
Right.
Anything else I can do with that box?
You can run pretty much anything within the Hypercycle container, right? So, I mean...
Okay.
If you were to look what's inside the Hypercycle, there is something inside the Hypercycle is actually called the AIM. Inside that AIM, if you log into it, it's like you're logging into an actual, let's say, Ubuntu machine. You can install whatever you want on it. If you think people are gonna buy it, you can install it. Like, it's basically you can have a corner store and sell whatever you want. You can sell drugs, guns, ice cream, whatever you want. If people want to buy it, nobody can stop you. Okay. I don't recommend you sell things that are illegal, wherever you are, but technically you can. Okay, it's like if somebody buys the phone and then they use the phone to sell drugs. Is that my fault? Maybe it is, because I want them to sell drugs, because I want them to use drugs. Maybe it's not. But my point is that if I make phones, I'm an enabler. So Hypercycle is an enabler. It can get you to run whatever you want. If you want to get things up and running very quickly, there are a lot of things the new net is doing, SingularityNET and whatnot, so you can have a lot of AI code written very quickly and put in it, and you can start like generating a lot of revenue and so on and so forth. But I want to get back to that point of wealth creation, which I really, really think that you might like. So when you introduce that value creation, that coffee shop to the machine, and you think of a machine, let's say you have 500 of those machines, and you, Lisa, you're talking to somebody who needs AI computing, okay? You tell this person, hey, I have 500 machines. I will turn them on once you actually give me that contract so I can compute the stuff that you want. That's scenario A. Versus scenario B, you show them a proof that for the last 6 months, you had some phenomenal proof of uptime every 10 seconds. You have a proof of every single GPU and CPU that they're actually doing heartbeat. Boom, 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 boom. All of them, they're running, they're available, network speed. That proves temporal coupling. That is what tilling is. It's giving you that capability, that power. So when you go on and tell that customer, look what I have, that customer is going to be like, holy shit, I want to use the infrastructure. And that is a value creation. That is wealth creation that you're doing, because now what you have is something more valuable than what it was before. And we give that to all of our customers.
All right. Great. I have another question. Let's see. I've been learning more about lattice-based cryptography. Would it be useful in this type of system, or too computationally costly? And I had the same question, because of course we'll have to ward off post-quantum crypto attacks in the not too distant future, and we might need that lattice-based stuff. So what are your views on that?
Dan, you want to take this?
Yep. I've got some background sound. Sorry about that.
That's all right. Thank you.
Yeah, I was actually just typing out a comment about this, but I can answer that question and maybe answer the more general question about what we're doing in terms of hashing algorithms and signing algorithms. You know, our general philosophy is that cryptographic algorithms all come with an implicit expiration date. We don't always know what that expiration date is, but they always come with an expiration date. So if we're going to design long-lived systems, then it's really important that we design them in a way that we can update those things over time. We can update the hashing algorithms, and we can update the signing algorithms. And if we're leaning heavily on features that those things provide, you know, elliptic curve signing algorithms, for instance, and elliptic curve public keys in general, they provide all kinds of interesting features that you can use. But if you use any of those, then you're trapped. You're locked into that particular system. So at the lowest level in our architectures, where these things are employed, we're making use of them in ways that are using basically no features. We're just signing with the signing keys. That's all we do. And all we care about is that there is a way to sign and there is a way to verify a signature. That's it. And likewise for hashing, we're just doing hashing. That's all we do with the hashes. All of our hashes are self-identifying. So you look at the first bit of the hash and it tells you that it's a hash, and it tells you what kind of hash it is. So they have an extra byte at the beginning of it. I think I said first byte. And so right now, you know, we picked the most boring crypto that we could. It was SHA-256 and SECP 256R1. That's our default hashing algorithm and signing algorithm. But we can expand those whenever we want. We have an experimental version running that uses Blake 3 and uses EC DSA 25519. The signing algorithm currently used, I'm answering the chat now, is SECP 25601. So yeah, really, really boring stuff. It's the same crypto that's used everywhere else, and we can upgrade it at any point because we're not tied to those at all. And so when the day comes to upgrade that, in the sense of adding more potential hash algorithms and adding more potential signing algorithms, all that means is that as clients update, they'll be able to make use of those new algorithms seamlessly with the data structures that they've been using already. They can just extend those data structures that they've been building with those new algorithms, either hashing algorithms or signing algorithms. And clients that have updated to be able to make use of that new stuff will be able to read it, and others will throw an error that says, sorry, you use this stuff that you don't have yet. Yeah. It's a form of ECDS. Exactly. I'm answering the chat again.
Okay, great. All right. Thanks a lot for clarifying that. Ben, you have to take off. You said you had to leave, so thanks a lot for coming. I'm going to talk to Toufi and Dan for just 5 more minutes because we had one thing that we still wanted to talk about, and I just wanted to make sure that we say goodbye, and we'll talk to you soon. Thanks, Ben.
All right, yeah. Thanks, everyone. This has been good. It was always cool to get news about a project in the public setting. So this deal with the boxes is super cool.
Super exciting, yeah.
Ben, Dan, and I might see you tomorrow in Mario for something that is super cool as well. So we'll let you know.
Tomorrow. All right. All good. All right. Bye-bye.
All right.
Which I will be prepared for the next session with Lisa. I cannot tell you, Lisa, about that yet until we have.
Okay, don't keep it quiet then. Don't let me know. Okay.
Right.
All right, great. So in the 5 minutes we have left, I wanted to make sure that we talked about you were talking about the extended utility native token.
Yes, I've touched on it a little bit when somebody asked that question about what's the whole AGIX and HYPC and all of the stuff, which is an amazing, amazing question. I love those questions. You know why? Because many people from outside of the crypto world, they're always asking those questions like, why the hell you need all of those tokens, coins, and those are very good questions. We cannot look at those questions and say oh, they don't know what they're talking about. We really need to get the remaining 99% of this planet. So in order to do that, we really need to start figuring out ways of how we make it super easy for developers from outside of this crypto world to truly start seeing value that they can actually measure when you compare it to centralized entities. Centralized. We need to, if somebody wants to enable what we enable, let's say having the smallest module of AI to talk to another module of AI. If they were to do that today, whether they are the King Kong of Microsoft or the King Kong of Google, they still have to rely on a third party. And if anyone tells you otherwise, they would be lying or don't know what they're talking about. Today, they have to rely on a third party. We come in with a method that they do not have to rely on a third party. They have heard before that you don't have to rely on a third party, and it turns out you do. It's called a ledger, and then it's called those that they call themselves interoperability layer, which is layer on top of layer on top of layer on top. And those developers, they know their stuff. They look deeply and they're like, wait a second, are you fooling me? That's not peer-to-peer. But guys, we're that close to start truly delivering on the whole promises of the whole crypto, true peer-to-peer. And this is extremely huge for all of us because it reduces the friction tremendously. So when they start comparing to Oracle, who's providing them with that a channel to connect between each other, then they find out that this is a lot faster, a lot more secure, and a lot more efficient. So then there you go. With that, if you save 99.9% every single time you have your nodes talking to each other, with Microsoft, you have like 580,000 nodes. You have in Google, like, I don't know how many in Google, last I checked, it's probably the same as Microsoft. And it's like each and every one of those, they can become a little bit smarter, but also everyone's basement, they can be running a node that became smarter. And with that, could also answer questions that we didn't answer. Somebody asked, do you think OpenAI would get to AGI first? Guess what? If you ask OpenAI themselves, they don't even know the answer to that. But do you want them to get there first, or do you want all of our global civilization to get there first? And chances are you want the latter, because you don't want a single entity to get there first. We are here to enable that latter, and we invite everyone to work with us to get there. So that's what we're doing.
Okay. And that had something to do with the extended utility native token?
Yes, absolutely, because like that token,
Okay.
that token is the container, like we're expressed with the AGIX. So when you put AGIX inside it, you can put USD inside it.
That's what you meant.
Which
You
means
can put your other tokens.
Agnostic. We're not here to compete with tokens. We're here to enable any token that you've got. You're not competing with us, brother. Okay, you're competing with like centralized entities or with each other. Keep on going the competition.
Because you want to run everything, right?
You can put that in the country and get a lot more efficiency. Then you can compete with the Oracle of the world, and I mean Oracle as a company, and not the oracles of the blockchains.
Right. Okay, great. And let's see. I posted a link to an article by Ben. Someone was asking if we thought that. It's kind of the question that we get all the time about do you think GPT-5 could achieve AGI, or do you think it will take more versions? Just a little reminder, I think Cory Doctorow said it best, that waiting for an LLM to turn into an AGI is kind of like looking at a horse and buggy waiting for it to turn into a diesel engine.
Right. It's amazing.
So the answer is no. And I posted that in the chat with the article that Ben wrote about it. And let's see. So I just want to make sure that we are clear about that these, so people could set up one of these computational nodes. The box will be coming soon in the coming months.
Yes.
The nodes are something that people could run now if they wanted.
Yes, if
they can run a node.
HyperPG can help them right away. If they have big, huge computers, you can help them right now. By the end of today, you can be up and running. But if
you could be up and running,
right?
And then if you want to buy a computational node, that's also something that is available now. That's why you had the bottleneck of nodes, because more people have purchased them than you have the nodes to run, right? So this is happening now, and they can go to hypercycle.ai to get started.
Yes, and somebody realized here, I think in your audience, it said like, which side would your AI wife or AI husband be on? And they kind of realized that I'm already there, because after 3 divorces with Homo sapiens, I'm actually considering now, like, the 4th AI marriage, and then that is it. I can no longer divorce. So I don't know how they found out.
Why? What are you talking about? That marriage doesn't mean you're stuck with them forever. Marriage is just, you got to do just a short term.
That was Ralph UPS who asked that question.
Drug induced.
I found it funny. So I'm like, I should probably.
It is funny. People are very, really want to know about their AI companions.
I love your audience. All these questions, like this is a lot of fun crowd.
It's a great,
It's good to see that. It's great.
It's a great group and good questions. That's why I was really trying to make sure that we got to all of them, and I really appreciate that we were able to get to all the questions this show. So thank you so much for coming. I want to encourage everybody to watch the podcast where we get in a little deeper into like all of these subjects. And thanks a lot for coming on the show, and we will talk to you later. All right.
Thanks for having me.
Goodbye, everybody.